Okay, so we're on page 65, section 1.9, and we're looking at interpreting graphs, and there's two types of graph here. One is kind of from like an Apple Watch, or Garmin has a similar product, right, and other brand names. And then here's a pie chart kind of showing during day activity. See how it says excluding sleep. So this looks like it's all day, right, from 12 a.m. to the next day, where the other one is just looking at the waking hours. So I'm going to have you pause and answer questions 1 through 4. So pause, try them on your own, okay, and then we'll come back. Okay, so the first question says, what percent, right? And so when they ask for a percent, we know that we are going to divide and we are going to multiply by 100. So we are going to divide our two numbers, part by whole, and then we're going to go ahead and multiply by 100. And then we want to know when they're very active, okay? So very active is 22 minutes. And you know that you're going to have to divide by minutes. So with percent, your units have to cancel because percents are unitless. And so we really need to know the total amount of minutes that this person's awake. So you can use a calculator, but you're going to multiply this by 60 because there's 60 minutes for everyone, and then add the 1. So that's going to be 601. Here we have 3 hours times 60, which is what, 180, and then plus, so 190. Here we have 60 and 45, so that looks like it's 105. And then don't forget that the 22 minutes would also be part of their day. So these numbers all need to get added. And again, you can use a calculator. So you have 601, let's see, so add 601 plus what, 190 plus 105 plus 22. So it looks like there's 918 minutes that the person's awake, and of those, they're very active for 22. So cancel, you're going to divide and then multiply by 100. And that is what is going to give you a percent for that one. So if you do that math, it ends up being about 2%. Oopsie, 2%. Yeah, that just looks bad. Sorry, I'll try again. So about 2%. Okay, the next one, what percent? So again, in my mind, I'm like, oh, anytime someone asks me to find a percent, I am going to divide things that have the same unit, and I'm going to multiply that answer by 100. So what percent of the day? Now we're focusing on the day. All right, so does he sleep? All right, so there's a couple ways to do this, and you might have done it differently and so forth. First of all, we have to figure out how many minutes are in a day. So there's 24 hours in a day. So if I take 24 hours in a day, and I'm just going to erase some of this so we have some space over here. Okay, so I know there's 24 hours in a day, and each hour has 60 minutes. So I'm going to go ahead and multiply that. And again, you can do it on a calculator. So there are 1,440 minutes. Say 1,440 minutes that the person is awake. Now, we could then figure out how many minutes they're sleeping. So on this previous problem, we had that there were 918 total minutes that this person was awake. So that means the rest of the minutes they must have been sleeping. So if I subtract that 918, I get 522 minutes that this guy is sleeping. So I could cancel my units, divide, and multiply by 100. And on that one, I think I get about 36% for the answer. Now, some of you might be thinking like, well, couldn't I do something else? And yeah, I usually can do more than one. So you could take that answer, that 918 awake time minutes, divided by the 144 minutes. And so if you divide that and multiply by 100, you're going to get that an answer of about 64%, right? But this is their awake out of their total. So this is the percent of time they're awake. But remember, percents add up to 100%. So you're either awake or you're sleeping. So you could subtract that from the total of 100% and get 36%. All right, so that's another option. Sometimes subtracting what you don't want from 100% to get the answer you do want is super helpful in statistics. An example would be like, say I want to find the probability that people have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or more children. So I would have to, if I wanted everybody, I would have to find every single person that has 1 child, 2 child, 3, 4, 5, 6, 7, 8, 9, and go for it. The other thing I could do is maybe have a sample of 1,000 people, and then I could count those people that have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so forth children. But it actually sometimes is easier to find the people that have no kids. So the people that never had children, and then get the percent of those people and then subtract from 100% to get the people that had 1 child, 2 child, 3 child, 4 child, 5 child. So sometimes in statistics we do that. We just find what we don't want and subtract it from 100%, and it's way easier. All right, so let's look at the next question. So this one is saying, during which period of day does most of his light activity occur? So light activity is kind of this turquoisey green. So you can kind of look at the chart and say, well, you know, there's a little bit right there, right? A lot of it kind of occurs right in here. So maybe, you know, I don't know, 6:30 to about 9 maybe. And then it looks like there's a chunk kind of maybe in the 4 to 6 range. A little bit around that 8 p.m. mark, and then a little bit around that 10 p.m. mark. Okay, so you can kind of look at that. And then 4, what information does each graph give that the other does not? This kind of bar graph up here shows when he exhibits all activities throughout the whole 24-hour day, but you don't really get to see the exact minutes, you know, so you just kind of see in general, but you don't see exact how many minutes he's doing each thing. Pie graph tells you the total time that he spent when he was awake, but you don't really know when those things occur. So you don't really know when he's being very active or when he's sedentary. You could kind of guess. But again, this is only showing when he's awake, and it's showing exact minutes, but not when those minutes occur, where this is showing the whole 24 hours, and you can tell when he's active and when he's not, but then also it does not tell you exactly how many minutes. All right, why don't you pause and go to the next page. Okay, so here I just took a screenshot of this. First of all, just note that when you want to compare part to whole, then you're going to want a pie graph. Okay, so part to whole, you want a pie graph. And again, pie graphs, you know, obviously a circle. You need a title. You're going to have to divide these into little segments of kind of what sliver has what. These should have labels, and they should also have a percent on them typically. Okay, so we're comparing part to the total, and that's when you use a pie graph. So say you have some data here. All right, so we have some characters. Now, see this over here. If you go to multimedia on MyMathLab, and that's one of the choices under course content, there's a video explaining this. So you can watch their video. It might and probably is way better than mine because they have big budget. But anyway, I'll still explain it, but if you would rather watch their video, go for it. So the thing is, with a pie graph, you need to know the wedges. And so if you think of one thing you know about a circle is there are 368 degrees in a circle. Oops, I don't know why I did percent. Sorry, 360 degrees. So, and these are just frequencies. So again, we need percent. So remember, we need relative frequency because it's going to put it in perspective. So the first thing we're going to have to do here is add these all up and get a total. So if you add those all up, it looks like I think there's 34. And so to convert things to a percent, you always take the part divided by the total. So we're going to do that on each one. 3 out of 34, 4 out of 34, and 19 out of 34. And those are going to give you decimals, and then you can multiply by 100 to get percents. But the problem is, to make a pie graph, you need these lovely thing called degrees so that you could use a protractor to figure out the angle. And so once you get your percent, remember to use a percent, you're going to take your decimal, right? Percent in decimal form. So like one of these, like this one might be 0.24. So before we move the decimal, before we multiply by 100, this is the decimal we get. So to use a percent, you put it in decimal form and you always multiply. So to create a percent, you divide and multiply by 100. To use a percent, you have it in decimal form and you multiply it by whatever you want. So in this case, I'm going to multiply it by 360 degrees, and that's going to give me how big my angle is. So why don't you pause right here, and we're going to look at the chart below. Okay, so if you look down here, the book is super nice. They tell you how they got the percents. So again, they got the total, and they took part divide by total, and again, multiply by 100 to get the percent. So divide, multiply by 100, divide, multiply by 100, divide, multiply by 100. But they don't show you really how they got that guy, or that guy, or that guy, or that guy. So remember, to use a percent, you would take the decimal form of it, so like say 0.56, times, because you're taking a percent of the circle, which is 360 degrees. So to use a percent, you always multiply. And so if you multiply, you would get that angle. Now, once you get that angle, you kind of have to eyeball these. So for example, like 85 degrees, if this were me, I'd be like, well, 90 degrees is straight up, so 85 is a little less. 180 degrees is half of a circle. So if I'm like, well, you know, that's 180, go a little extra, that's probably 201. And then you just kind of have to eyeball it. 30%, so if you think of a circle, 90 is this guy, so 30% would look like a third of it. So you can kind of eyeball to get your best. But if you wanted to use a protractor, that'd be perfect. But usually we use computers anyway. All right, so then you're going to label each with the label of the category, and don't put the degrees, put the percent. And then you need a title, and then you're good to go. So there's directions on the top of page 67, but what I want you to do is try problem number 5 on your own and see how that goes. Okay, so we're on the bottom of page 67, and I wanted you to try this on your own. So we're looking at kind of, I guess, how someone spends their workday. So time spent at work, or how someone maybe spends his or her time at work. So, I mean, you can come up with however you want to label it. So, those are all kind of debatable, but you want it to make sense. So here we're looking at Ian, I guess his name is. So we're going to go with Ian's workday. So Ian's workday. Or you could use work habits, whatever you want. Okay, so first thing is again, numbers by themselves, like, oh, I spent an hour doing that. Well, that doesn't put it in perspective. If you normally spend 1 minute doing it and it took you an hour, then wow, that took you tons of time. If it took you an hour to do something that takes most people 5 hours, that was really good. So again, remember, percents put things in perspective. So I think if I add this up, I think he's working an 8-hour day. There's 4 hours there, 5, 6, 7, 8. Yeah, he's working an 8-hour day. So first we need to get percents. So remember, you're going to take, like, units have to match. So like hours divided by hours, units cancel. And so you divide. So like 1.5 divided by 8 equals, and then multiply. So you get what? 0.1875 multiplied by 100. So 18.75% of his day is spent in meetings. Okay. I could do the same thing for computers. So I could take 2.5 divided by 8. And again, notice my units match so that they cancel. So 2.5 divided by 8 is, and multiply by 100. So 31.25%. And again, there's no units on these because they canceled. Of his time is on computers. And I could do what? 1 divided by 8. And multiply by 100, so 12.5% of his time, and there's 2 of those, right? So that would be calls and lunch. And I could do the 0.5, so half over 8, and again, multiply by 100. I would get, what, 6.25%. Now, if you round, they might not add up to 100 because of rounding, so that's why I didn't round. But sometimes they might add up to 101%, 99 because of rounding. So next you're going to convert these to decimals and multiply by 360. So for example, this first one, I'm going to go back to decimal form, and I am going to take a percent of 360 degrees, and that's going to tell me my degrees. So 0.1875 times 360 is a 67.5 degree angle. So I would eyeball that, not 90, so about right there. All right, so finish this, and I'll come back in another video, and we'll finish it up.